Alright, this is the start of Chapter 3, Forces and Newton's Laws. And so we're going to start with Section 1, which focuses on forces, and we're really going to get into the idea of what is friction. So here we go. Alright, what is a force? That's what we have to study first before we can get into anything else. And so the idea of a force is simply a push or a pull. And so forces can be real obvious. You can see them happen. So you can push something and you can see it move, or they can be unnoticeable. So you can push something and it doesn't move. It just depends on the object and what's happening. So it can cause the motion of an object to change. So that's something to just think of. So that's kind of the thought process with forces. So kind of an example here, if you've ever played the game of pool, you know that if you take and you hit one ball at rest, it goes and it hits another ball and then it hits another ball. The force that you hit the first ball, it causes it to hit a second ball. And so you are using forces to cause each ball to hit another ball. And so that's just an example of using forces, and specifically starting with an object at rest to cause another, a force is being used to cause another ball to hit another ball. So that's just kind of an example of forces there at play. We're going to talk about a definition here. The definition of net force. Okay, so net force, right? Net force is the sum of all the forces acting on an object. So you have to think about what all is playing on an object when you look at it. So if you look at this guy pushing the push, he's pushing this way, but you have to think about all the other things that's acting on this. So what's the net force? You have to think about, we're going to talk about gravity, pushing down. You're going to talk about the floor pushing backwards. We could get into air resistance possibly pushing the other way. So adding all those different forces up together. That's the net force. Okay, first of all we have something called balance forces. Balance forces are forces that do not change the velocity of the object. So the key word there is that they do not change the velocity. So, we look at over here this picture, you have these two lovely ladies, and they're both pushing this box, okay? And so notice that, look here at the arrows. One's pushing that way, one's pushing that way, and so they're both pushing with the exact same force, but they're pushing in opposite directions. And so what happens? They cancel each other out. So the overall net force, when I add those two forces together, is 0. So when the net force is 0, we say that that is a balanced force. They cancel each other out. You can have the opposite happening though, where the forces actually cause a change in velocity. So now you actually have, we have these unbalanced forces, and unbalanced forces can happen in a couple of different ways. I have an example here of this lovely lady and this gentleman. They get on the same side of the box, and they're pushing in the same direction. Notice that you've got the arrows. One is going, this way, one is going this way. And so what happens? You add them together, and look, the net force is going in an overall direction of this way. So guess what? You're going to have overall movement. So they're going to cause that box to move in this direction. So they're going to be able to actually get that box to move. You can think about it this way too. Here's another example of unbalanced forces. Look, you have two people. Again, they're pushing in on opposite sides of the box though. But look, this lovely lady here, she is pushing this box with a larger force than the gentleman, which still kind of cracks me up. You've got this smaller little gal and this bigger guy, but she's pushing harder. And so what happens is that when you kind of like basically add those arrows together, you get an overall net force in this direction. So that's going to cause this box to move this way. And so you get movement of the box, which means that you have a net force or an unbalanced force, which is going to obviously cause the box to move. So those are kind of two examples of unbalanced forces. When an object actually moves, so when you get that unbalanced force, you get something called friction. Friction is simply that force that opposes the sliding motion of two surfaces touching each other. So, if you have an object and you allow for it to move, so example, a skateboard. You send this skateboard and you allow for it to start moving, eventually the skateboard is going to slow down. If I push a skateboard in like the classroom and give it a little push, eventually it's going to slow down and stop. Why? Because of friction. Friction is eventually going to cause it to slow down and stop. It won't roll forever. The amount of friction between two surfaces depends on two different factors. So, how much friction will an object have? You can look at it and say, well, there's two things that really affect how much friction something has. The first one is, what kind of surfaces do you have? We're going to look at this a little closer here in a minute and explain why do we even have friction. And basically, and that'll kind of make sense a little bit more. The other thing is that the amount of force pressing the surfaces together will affect the amount of surface. If you push two surfaces tighter together, you're going to have more friction. So, if they're very loose, not so much friction. Push them together farther, more friction. Now, this is going to make sense with what causes friction to explain what is friction a little bit more. If two surfaces are in contact, you're going to get sticking. Now, what you have to understand is that if we look at this picture down here at the bottom, you have to understand that every single surface, no matter how smooth it is, has ridges. If you were to look at a surface, even like the smooth lab tables in our room, or like even like the smooth screens of like your iPads or your phones, if you look at them with a microscope or something, you would see that there are ridges on everything. Now, of course, the smoother the surface, less ridges there are, but everything has these little ridges. And what happens is that when two surfaces come together, depending on the number of ridges they have, they kind of glide over each other, and it's kind of like going over a bumpy road on a car. They kind of stick, they kind of, just kind of get stuck. And so what happens is that basically they kind of, like I said, they get stuck, they stick. They also use the word up here, welding. There's kind of a welding that happens when the two surfaces touch each other. And we call these things, when they get welded, we call these things little micro welds. And that's the source of the friction that happens. So, like, if you look at the picture, when these kind of get these little caverns, we get these micro welds, and that's what causes friction to occur. So, if you think about it, surfaces that are more bumpy, we're going to have more friction. And surfaces that are pushed harder together, so that's kind of the points we're making here. Surfaces that have more micro welds, meaning more bumpy, are going to have more friction, and surfaces that have more force between them. So if you push these two surfaces together, look, you're going to cause more micro welds. It's going to make it so that there's going to be more sticking, and it's going to make it so it's even more bumpy. So that's why it's important to make sure that you decrease the friction as much as you can in certain objects to make it so that there's less micro welds. That's why you usually put some kind of oil in between surfaces that have a lot of contact. There's three main types of friction that we focus on: static friction, sliding friction, and rolling friction. And we'll go through each one of these and what it is, and specify and kind of define it. The first type is static friction. I think of like standing still when I think of static, like you're not moving. Static kind of means, like I said, you're just kind of motionless. So static prevents two surfaces from sliding past each other. And so basically static means that there's no movement. And so I put an example over here, like you're pushing a cardboard box filled with books. So it doesn't move. So it's just basically static friction is the friction from that doesn't allow it to move. So this box isn't moving. Then you've got sliding friction. So now you've overcome the micro welds, you're actually able to move the object, and so now we have this friction called sliding friction. So this is the force that opposes the motion of two surfaces that actually can slide oppose each other. And as I said, this occurs when there's enough force to actually break the micro welds. And so you're pushing a cardboard box, for example, you push hard enough to make it move, and then so of course if you stop pushing hard enough or applying enough force to where the box no longer can move, that sliding friction has now went back to static friction. There's a very specific type of static friction that occurs when the wheel and the surface touch each other. So it's kind of easy to remember rolling. What's a wheel have to do? It has to roll. So basically this type of friction that prevents basically anything that kind of rolls, you got your wheels, anything that has traction basically, is called rolling friction. It basically refers to tires on vehicles, and it's just basically, a lot of times we even, like I said, use the word traction instead of friction. And so just another type of friction, and it's a type of static friction. And so that's our third type. So that is the end of types of